Hi, my name is Edgar Roberts, and I'll be talking about scheduling from the Operations Management book, 12th edition by William Stevenson. So, what is scheduling? It is basically anything that has to do with establishing the time of the use of equipment, facilities, and human activities in an organization. No matter what kind of activities is going on in an organization, pretty much every organization is going to have scheduling. It's going to happen. When scheduling is done right and is effective, it can help with cost savings, and it definitely increases productivity, and it also has some other benefits. All right, so let's talk about scheduling operations. There's three different ones that are talked about in this chapter, and the first one that we're about to talk about here is high volume systems, and then you have intermediate volume systems and low volume systems, or low volume scheduling, also known as job shop. And there's another type of scheduling called project scheduling, but it's not talked about in this chapter. Scheduling in high volume systems is when workloads are assigned to specific work centers and that are determined to determine the sequence in which the operations are to be performed. And when jobs follow the same sequence, they're known as flow systems. And scheduling flow systems is referred to as flow shop scheduling. And some examples of high volume products are things like personal computers or autos, radios, television, appliances, or stereo equipment. And examples of high volume services are things like news broadcasts and cafeteria lines and mass inoculations. And these are services that are very repetitive. And one of the main things that there needs to be in flow system is line balancing, because this helps assign certain tasks to workstations so that they can satisfy the technical constraints and then are balanced to the respect the equal work times among stations. And in high volume systems, they usually require automated or specialized equipment for processing and handling. And the next type of scheduling operation is intermediate volume systems, and this falls in between the high volume systems and made to order output of job shops. Like high volume systems, intermediate volume systems also normally produce standard outputs. But the one difference with this than high volume is that the volume of output is usually not large enough to justify using continuous production, so it's better to process them intermittently. So intermediate volume work centers shift from one job to another, but in contrast to job shop, the size of the batches are usually pretty large. And some examples for intermediate volume system products can include things like baked goods and foods, paint, and cosmetics. And the three main issues in these systems are the run size of jobs, the timing of jobs, and the sequence in which the jobs are processed. All right, now moving on to low volume systems, also known as job shops. These are a lot different than the high volume systems and the intermediate volume systems, because the products are made to order, and they're usually a lot different in terms of like the processing requirements and the materials that are needed, processing time and processing sequence and setups. And because of these things, job shop scheduling is usually pretty complex. So there's two basic issues that come into play for scheduling in job shops, and the first one is how to distribute the workload among the work centers, and the other one is what job processing sequence should be used. And loading is the assignment of jobs to processing work centers. And there are visual aids that can be used for helping loading and scheduling, which are called Gantt charts. And these charts were used in the early 1900s for industrial scheduling. These charts help organize and visually display the actual or intended use of resources in a time framework. There's a lot of different types of Gantt charts, but the two most popular, most commonly used are the load chart and the schedule chart. And the load chart is a chart that shows the loading and idle times for a group of machines or a list of departments. And a schedule chart is a chart that shows the orders or jobs in progress and whether they are on schedule. There are two different approaches used for load work centers. One is the infinite loading, which is jobs that are assigned to work centers without thinking about the capacity of the work center. And the other one is finite loading, which are jobs that are assigned to work centers that do take into account the size of the work center, the capacity of the work center, and job processing times. Just like there's two different approaches for loading work centers, there's also two general approaches for scheduling. One which is forward scheduling, which is scheduling ahead from a point of time, and then the other one is backward scheduling, where you schedule backwards from a due date. Not only do managers use the Gantt charts, they also usually rely on input-output reports to manage the workflow. And input-output control is managing workflow and queues at work centers. And another approach that can be used to assign jobs to its resources is the assignment model, which is a linear programming model for the optimal assignment of tasks and resources. Sequencing. Sequencing is important because even though loading decisions help determine the types of machines and work centers that will be used for specific jobs, they don't indicate the order in which the jobs are waiting at a given work center to be processed. So that's where sequencing comes into play, and that helps to determine the order in which jobs at a work center will be processed. And workstations are the area where a few workers or one worker will perform similar work. Well, workers and machines will perform similar work. And because there's normally several jobs that are waiting to be processed, there's a priority rule, which is the simple heuristics used to select the order in which the jobs will be processed. Helps prioritize them. And job times are helped with this because a job time is the time that's needed for a setup and processing of a job. Priority rules can be known as either local or global. If they're local, then they focus on information that has to do with a single workstation when it's establishing a job sequence. And global is when there's in-corporate information from multiple workstations when establishing a job sequence. So here are a set of different priority rules. There's first come, first serve, which are jobs that are processed in order when they arrive at a machine or work center. Then there's the shortest processing time, which are jobs that are processed according to the processing time at a work center. It's the shortest job first. And then there's the earliest due date, which are jobs that are processed according to the due date, earliest due date first. Then there's critical ratio, which are jobs that are processed according to the smallest ratio of a time remaining until due date to processing time remaining. Then there's slack per operation, which are jobs that are processed according to the average slack time, which is the time until due date minus remaining time to process. They compute by dividing slack time by number of remaining operations, including the current one. And then there's rush, which is the emergency or preferred customer first. So sequencing can be frequently judged in terms of one or more performance measures, and the most commonly or frequently used performance measures are job flow time, job lateness, make span, and average number of jobs. Job flow time is basically the amount of time from when a job arrives until it's finished, and job lateness is the difference between the actual completion date and the due date. And make span is the total time that's needed to complete a group of jobs from the beginning of the first job to the completion of the last job. And then average number of jobs is the jobs that are in a shop that are considered to be work in process inventory. And the average work in process for a group of jobs can be computed using a formula, which is average number of jobs equals total flow time divided by make span. So Johnson's rule is a technique that's used for by managers to help minimize the make span for a group of jobs that are to be processed on two machines or two work centers. But first, to do this, there are certain conditions that need to be met, and those conditions are job time has to be known and constant for each job at each work center. Secondly, job times must be independent of the job sequence. Thirdly, all jobs must follow the same two-step work sequence. And then fourth, a job must be completed at the first work center before the job moves on to the second work center. And when applying Johnson's rule, it begins with a list of all the jobs that need to be scheduled and how much time will be required for each job at each workstation. And the sequence has to be determined by certain steps, which are selecting the job with the shortest time. If the shortest time is at the first work center, schedule that job first. If the time is at the second work center, then schedule the job last. And then secondly, eliminate the job and its time from further consideration. And thirdly, repeat steps 1 and 2, working toward the center of the sequence until all jobs have been scheduled. Many times it's assumed that the machine setup times are independent of processing order, but that's not always the issue. Sometimes a manager may want to schedule jobs at a workstation taking on those dependencies and taking those dependencies into account. So there are ways that you can sequence jobs to help minimize the total setup time. And one of the simplest ways to do this is to list all the possible sequences and determine its total setup time. And this is easy to do when the number of jobs is like 2 or 3, but sometimes it gets really complicated and there's a lot of all types of alternatives, and so the numbers get larger and you can't really do that manually anymore. So sometimes the manager will use a computer to help generate the list and identify the best alternative. So yeah, and more than one alternative can be tied for the lowest setup time. So there's a lot of reasons why scheduling can be difficult. It's definitely not an easy task. One of the main reasons is just due to the variability of all the setup times and processing times. Interruptions and the changes in the set of jobs can be really difficult. Another thing that makes it real difficult is that there's not really a method for identifying the optimal schedule. It would be pretty much impossible to sort through all the vast numbers of possibilities to get the best schedule. So this is definitely an ongoing task for a manager who does scheduling. One thing though that does really help with scheduling is just the use of computer technology. It just makes scheduling so much easier for many people, many managers. So there are several different things that a manager can do to help minimize the difficulties of scheduling. The first one is set realistic due dates. Don't set something that seems impossible, but just set realistic due dates. Second thing you can do to minimize scheduling difficulties is to focus just on the bottleneck operations. First try to increase the capacity of the operation, but if that's not possible, then just focus on the bottleneck of the operation, and um, and then schedule the non-bottleneck operations around the bottleneck operations. Third thing you can do is to think about maybe using lot splitting for large jobs, and that usually works good when there are large differences in job times. So the theory of constraints was an approach that Eli Goldratt came up with, because before him, most everyone focused simply on just the bottleneck operations, but he believed that the output of the system was limited by the output of the bottleneck operations. So he believed it was really important to schedule the non-bottleneck operations, where it didn't minimize um, in a way that minimized the idle time of the bottleneck operations. So therefore, as long as the bottleneck operations were used effectively, the idle time of the non-bottleneck operations wasn't a factor of the overall productivity of the system. And the observations that he came up with have been narrowed down to a series of scheduling principles, which are an hour loss of a bottleneck operation is an hour lost by the system. The bottleneck operation determines the overall capacity of the system. Also, saving time through improvements to the bottleneck will not increase the ultimate output of the system. And then lastly, the activation of a resource is not the same as the utilization of a resource. Because a non-bottleneck operation is active does not necessarily mean it's being useful. And there is a intermittent production system that was come up with that's a lot simpler and less time consuming to use, which is called the drum buffer rope. Drum buffer rope conceptualization. And this is basically where the drum is the schedule, and it's what sets the pace of production, and then the buffer is the potentiality to constrain resources outside of the bottleneck, and the rope is what represents the synchronizing of the sequence of the operations to make sure that make sure there's effective use of the bottleneck operations. There's also some other different variations of systems that Goldratt came up with. One is the process batch. There's also the transfer batch, and then there's the theory of constraints, which is what we talked about, which emphasizes balancing throughout the system and uses a 5-step improvement process that's centered around the system's currently most restrictive constraint. And it uses 3 metrics to assess the effectiveness of improvements, which are throughput, inventory, and operating expense. So scheduling services are something that's needed mainly when there's the inability to store inventory services and the random nature of the customer request for service. And this is something that you usually don't see in manufacturing systems. They usually don't have to use this, but in some scheduling, you do have to use the scheduling services. And here are some of the different approaches that are used for scheduling service systems. I'm going to kind of run through these because I feel like I'm getting close on time. But you have the appointment systems, which are mainly for the control of timing of customers' arrivals in order to minimize the waiting while achieving a high degree of capacity utilization. And then you have reservation systems, which are which help enable the service systems to come up with a fairly accurate estimate of the demand of the system for a given time period and to minimize the customer disappointment that can come about by waiting a long time or the ability to obtain service. And then you have yield management, which is is something that's used with mainly with operating with fixed numbers, such as like rooms for a hotel or airlines, just things that work with fixed numbers. And then you also have scheduling the workforce, which is um, not demand management, but it's capacity management. And you have cyclical scheduling, which is like just a basic work pattern that's set, like work 5 days, have a couple days off, something like that. And then you have where you schedule multiple resources, where you basically just have to coordinate the use of more than one resource, like a hospital. They might have to schedule the surgeons and operating room staffs and admissions, special equipment, nursing staffs, and all that. So scheduling is really important in a business, and it can either really help the operation or it can really hinder it. So if it's done, it needs to be done well. But if it's not, then it will result in just uh, inefficient use of resources and possibly upset customers. So it's not enough for businesses to have really good quality or good design, and all those types of things. You have to really know how to make the business run, make it work, and you can't do that without scheduling.